All right, we are live. Good morning, everybody. I am Veena Duraisamy and developer advocate at Snowflake. Today, we are going to talk about a very exciting topic. But before we talk about Snowpipe streaming and how you could be running your streaming pipelines and whatnot, I would like to welcome Maria and Chase today to the show, who's the product marketing manager, and Chase, the product manager for Snowpipe Streaming Week 2. And firstly, welcome Maria and Chase to the show. Super excited to have you here and talk about all things Snowpipe streaming.
Yeah, thank you so much, Reno. Super excited to be here. My name is Maria Ho, and I am a product marketing manager here at Snowflake. Really excited to talk to you about just data analytics and streaming today.
Excited to have you too. And hey, Chase, you want to introduce yourself?
Sure. Yeah. Thanks, Vino. Yeah. Excited to be here with everyone. Chase Thomas, product manager over Snowpipe streaming and streaming ingest here at Snowflake. And yeah, happy to dive in and do some demos and have some fun today.
Fantastic. I know before we get started on the cool demos and seeing these features in action, I have some questions for you. I know Snowpipe streaming has been around for a while now, but why are we talking about it today? Like, what's new with Snowpipe streaming?
Yeah, so I am really excited to let you all know that our streaming V2, what we call the next generation of high performance architectures today is GA, which Chase will actually see and show everything to all of you in action. And so really just think of this sort of like a new foundations for how you can stream, your data into your platform, our Snowflake platform. And so we're really designed to solve really lots of like biggest data ingestions challenge for you through providing massive throughput, simpler costs for all of you.
That's fantastic to hear. And you said it's going GA already, right?
Yes, it is GA today.
Oh, that's fantastic. Okay, so today is a big day. And you tell us, because it's going GA today, what do you hear from the customers? And for folks who've been using this, what do we hear from them, and what should we know about it?
Yes, so let me go ahead and share my screen here. For those who missed our announcements a couple weeks ago, we actually released this report called MIT Technology Study with Snowflake. And in this report today, we're actually seeing that a lot of the companies are already seeing that AI is delivering massive value already. And so we can see that 74% already reported that they're seeing AI really increasing their productivity already and helping them to generate new codes, deliver more projects. But there are always a but. We're hearing a lot of like big obstacles from companies like integration complexity, right? Organization are struggling to bring all of your raw data, silo data from different sources, their systems. So you simply just can't, govern it, clean it or use it instantly for your AI until your data is reliably ingested or unified, right? So if you attended our conference last week, Build, our VP of Product Management, Chris Chow, actually touched on that, accessing the data is only just your first hurdle, but then the next is speed, right? So AI agents, recommendation engines, even cyber defenses depend on, fresh and immediate data access, which is why streaming is so important, right? So at Snowflake here, we really see that, streaming means like continuous fast flow of data generated from different sources like applications, right? IoT devices, we have sensors as well. So this is what we really think streaming is here at Snowflake. And it's not just about latency too, right? We also want to reduce your compute costs, storage costs. We want to really help you to accelerate your insights.
This is interesting. Oh, okay. I was going to ask, can you show us some examples from the industry of how people are using streaming? I think you already got it covered.
Yeah, so there are a couple of industry, as you all can see here. Basically, we're hearing it from our customers almost daily now. It's different industries. We have cybersecurity, obviously. We have retail. We're thinking about how companies from retail. They're thinking about how to improve or personalize their customer experience. We also have media or entertainment. We want to provide that live content personalizations. And obviously we have, financial, telecoms and public sectors. And also speaking of financial, we actually have a pretty cool, customer use case we can bring up later. So we're hearing it every single day now. By the way, I also want to speak about, how everything, our data ingestions come together here at Snowflake here. So I touched on how we want to solve your biggest, challenge, which is bringing your raw data into this one unified platform, right? So our Snowflake AI data cloud platform has built this end-to-end data pipeline journey for our customers. So we want to make sure that all your data is like ready for AI and analytics downstream. So obviously, we have a couple data ingestions options here, including our OpenFlow, Snowpipe, and today we're talking about Snowpipe streaming here. And in a second or in a minute here, Chase is actually going to showcase what is this new exciting launch that is GA today, right? So just do a little double clicking here. What Snowpipe streaming really is, at Snowflake is we want to offer, three big value props for our customers. Simplicity. We want to offer that ease of use, and then which means that no orchestration required, no infrastructure management, so everything is hands-free. You don't have to worry about anything, and obviously like cost effective. This is something that I'm super excited to announce, and this is part of our launch too. We want to deliver this like new predictable and flat ingest-based pricing model for our customers. And lastly, like I said, right, it's part of the unified platform, right? So our streaming actually deeply integrated with our platform. So you don't have to worry about, switching tools and things like that. Everything is like governed within the single platform via our Snowflake Horizon catalog.
Gotcha. This is fantastic. But also, tell me a little bit about this high performance architecture itself. Like, what does this mean for the end user? Do I still continue to use Snowpipe streaming, just that Snowflake had sort of built this new architecture under the hood and that's highly performant and cost effective for me? Or does that change how I use Snowpipe streaming today? Chase, do you?
Yeah, let me answer that. So we do get that question a lot, right? Is Snowpipe streaming's been around for a while. Why did we need to kind of build this new architecture? And fundamentally, when we looked at where our customers were headed, we looked at the amount of data that was scaling. Customers' data needs were increasing exponentially year after year, and the amount of data they wanted to get into Snowflake to get the value out of the platform was also increasing. And so when we looked at this, especially the high throughputs, where we think customers are going to be in a couple years, we really needed to kind of step back and look at our architecture and say, hey, is this set up to be where we need to be 3-5 years from now? And so ultimately we said we needed a new architecture that can take us to there and help us reach our goals. And so that's why we kind of created this new Snowpipe streaming high performance architecture. Is we need to support very high throughputs. We need a path for very low latencies and decrease those latencies over time and be able to really meet our customers where they are and where they're headed. And so ultimately that's what we wanted to do. And then at the same time, as Maria mentioned, we wanted to have a very transparent, easy to use cost model for customers so that they could predict where their costs will be as well, as they're scaling up the amount of data they're sending in. So all of that combined resulted in this new architecture that's more performant end to end, as well as on the client side, more efficient as well. So end to end, we want to provide better performance and latency, as well as provide, better total cost of ownership end to end as well. So what this slide is showing, for those that aren't familiar with Snowpipe streaming, we have basically what's called a channel. And this channel is where you can start streaming your data into Snowflake and do things that like exactly want semantics, as well as ordering of your data as it's coming into Snowflake. For those coming from Kafka, a channel is similar to a Kafka partition. Is that data is kind of partitioned in that channel and streaming in. In Snowpipe streaming, in our high performance architecture, we do also include a pipe now in between the channel and the table. So what this is showing is our classic architecture, which has been around for a long time. And then the new architecture, we include a pipe in there. And that provides additional features like we can cluster the data in flight, as well as you can perform lightweight transformations. So that's another real big value add of the new architecture, is that you can get these new features and capabilities that weren't possible on the old architecture as well.
Got it. And I feel like we have talked a lot about this, and maybe it's time we see this in action. I know, Chase, you have a very cool demo that you can show us. So let's switch over to the demo now.
Sure.
While Chase pulls that up, for folks who are watching, if you have any questions, please let us know in the comments. We will get to the questions by the end of the demo.
Awesome. So what we're going to be doing here in this demo is we're going to be streaming data live into a table, and we're going to be doing it from our new Python client. So one of the other big value adds of the new architecture is that we are multi-language now. So we have more flexibility for developers to get their data into Snowflake and to stream it into Snowflake. So I have a couple examples that we can go through, and we have the SDK and client side on the right, and then we have our Snowflake, dashboard here on the left. And so I've already set up the user, but there's obviously some setup steps to get your user created and the right authentication. And then what I've done is I have a table created, and then I have a pipe. Now you can also do a match by column pipe if you don't want to set up a specific schema. This one I've added a timestamp in here that you can do. And this isn't the most accurate timestamp, but it can give you an idea of when that data is landed into the table. So we should have a blank table here, and I'll just run this to make sure so we don't have anything in it. Now jumping over to the client. So again, this is all Python code. I've set up a couple things. I have a authentication set up that if you go to our quick start and getting started guide, we talk about setting up your user role and plugging that into our client. But I have basically the three components I need here. What is the database schema and the pipe that I'm going to be writing into? And so you can see that I've named it my pipe for this demo. And then this is that profile.json. This is where you put your authentication information, your private key, things like that. So I'm not going to show that here on this demo, but very simple to set up, just about 4 or 5 configurations in there. And so once we do that, we're going to open a client based on those connection information and auth. And then we're going to open that channel. So we're going to call it Python example here. And that channel, again, is how we start to stream data into Snowflake and into Snowpipe streaming. And then here we're going to send in I think I'm doing 1,000 rows of data, and I'm using Faker, which is a Python library that can generate, fake user data. So this is going to be like user data. It could be like, think of it like a clickstream or analytic use case where you're trying to track what users are doing on your website or orders, things like that, right? Very common streaming use case. So we're going to get all these user ID, and then this is where we actually append that row of data and start sending it into Snowflake. And then once we do that, we're going to wait for the data to be committed, and we can talk about that a little bit. And at the end, we'll get a channel status. So we can get a status of that data has been committed to the table, how many rows, et cetera, and then we'll check out the result in Snowflake. All right, so I'm going to click play here, and we're going to run that. And you see that we sent 1,000 rows of data very quickly. And it takes about 5 to 10 seconds for that data to land into Snowflake. And you see that we did that already. So this is that channel status. It says, hey, you sent in 1,000 rows. This offset token, this is how you can track progress of your data. So with streaming, you're doing continuous data, right? So this is, and we'll do a second example that we can kind of get a feel for that. It took about 7 seconds, and there was no errors, So let's go ahead and take a look at our table here. So we'll start with the count. And you see we got 1,000 rows, so everything made it. And, we can take a look at our data. And we got our fake customers, doing things here within Snowflake. So you can see if I didn't talk and I just hit play, in about 7 seconds, we would have streamed that directly into the table. So I'm going to close this down. I'm going to do a second demo, and I'm just going to slow it down a little bit. So we're going to kind of put a pause in between each row of data of about 100 milliseconds. And so this will simulate, continuous streaming of data. And we're only going to do about 500 rows. And every half a second, we'll actually query that channel status, and we'll kind of get information about what's happening as it's coming in. So let's go ahead and run that now. Get rid of that update. All right, so we're sending data in. You can see that we sent in about 60 rows of data. And then now you can see the data starting to land in Snowflake. So again, there's about a 5 to 10 second latency for it to be committed in a native table format that you can query. And then down here, you can see, we can see the lag of that data. So, anywhere from 20 to 60 messages behind as I'm streaming data in. And so you can see, since I'm sending it every 100 milliseconds, that is about anywhere from 2 to 6 to 7 seconds. So on average, the data is actually landing in about 4 seconds right now. And you can track the progress, how many rows we've inserted, the average latency time. Are there any errors? So once you get into more advanced streaming, tracking your error count becomes much more important as well. So we sent that all in. It's already landed, and again, we can kind of see that data is all in Snowflake as well. And then you can see here that we put the IDs in. You can see that number row 500 is there as well. So yeah, that's a couple quick demos. Yeah, Vina, if we have time, I could do maybe one more. What do you think?
I think we can do that other one too. We've got a few more minutes left.
Okay. All right, so I'm going to clear this table out. So this one's a little bit more advanced. So the question is, what if there's a problem with a row of data that I'm streaming in? How do I deal with that? Very common. And again, it all comes down to these offsets, that you're sending into Snowpipe streaming and into Snowflake. And that's how you kind of really keep track of, what rows have made it in. And so what we can do in this demo is I can actually say, hey, at row number 200, we're going to send in data that doesn't match my schema, right? So this is going into a table. What if I have some misaligned schema? What happens then? So in this case, once we get to row number 200, we're going to send in some bad data. And what I have is in this monitor, this monitor that I have, this channel status, it's actually looking at this row offsets as well as the errors. And so if that error count goes up, it will actually stop the process, and then we can then dig in a little bit. So let's go ahead and run that. We're going to go till about row 200. And so we can see we're at, it will take a little bit for it to start committing the data into Snowflake again. And so you can see we are about, 60, 70 messages, 20 messages behind. And once we get to row 200, it's going to send a bad message. Okay, so now we sent that bad message. And with that lag, it's going to take us a little bit of time to catch up and find that message. Okay, so it's detected that we had an error. And you can see here, this is the big thing here, is that, it detected that we had one row count that had an error in it. And then it gives us a general range. It says, hey, somewhere before 204, we had that problem. And then it finished committing everything that was in flight. So now if we come here to our table, we can look at it. We should have, so it says the final committed was 271. We had 271, but if we scroll down to 200, we should see that it's not there, right? So we go 199. So you can see that we're missing that one row. And so again, knowing that we had an error count, we can come into our source data. In our best practices, we also have a query here that you can run that helps you also detect if you have any problems. So if I run that query, we can see, hey, you're missing 200. We expected 200, we didn't see it. So really, really simple demo, a little bit more advanced digging into error handling. But the idea is that the client can track progress going into Snowflake. If you do see an error count, you can go troubleshoot, find out, where that problem was. And then as well, we do give you some error information as well, that there was something wrong with your variant, and then you can go and troubleshoot it. So, all right, so that's a little bit of Snowpipe Streaming's new architecture using Python.
Mm-hmm. That was very cool, especially the error handling part, because we all know sometimes the upstream applications would change the schema and then you would have no idea what's hitting you. And it's nice to see that there is a way to sort of not just proactively, like, just ignore the error record and sort of continue, but also dig in, like, see what's going on and how to handle that. That's nice to see that. But I have another question, which is more on the product level, which is I know we have not recently, it's been like 6 months now, like launched and announced Snowflake OpenFlow, and now we have Snowpipe streaming. So as a data engineer, how do I think about these and when to use what?
Yeah, yeah, absolutely. I get that question a lot. We at Snowflake, we're introducing new options for our developers, our customers, and a lot of these work together, and some are focused on more specific use cases as well. The great thing about Snowpipe streaming is that it is the streaming gateway, if you will, into Snowflake. So OpenFlow is actually one of my integration partners. And what OpenFlow is, it's a connector framework. And we're working on things right now. There's some things in preview, but any streaming connector on OpenFlow uses Snowpipe streaming, and we'll use Snowpipe streaming's new architecture very soon as well under the hood to get your data into Snowflake. So the simple way to think about it is, if you have a streaming use case and you're already using some type of connector library or connector framework in your system today, OpenFlow is probably going to be where you want to start. You want to look at, hey, I want to connect multiple data sources that are streaming into Snowflake. OpenFlow has built connectors for that is utilizing Snowpipe streaming under the hood and all the best practices. So that's where, as a developer, you probably want to start with OpenFlow. Now, for developers that already have custom applications, you already have custom Kafka clients and things like that, and you're working really down in that application and code layer, that's where you want to probably start with Snowpipe streaming. Now it's more about integrating an SDK into your flows rather than, relying on a connector framework that's a little bit more point and click, if you will.
Got it. I think that's very helpful. And before I go ahead with my own questions, I see that there is a LinkedIn user who has a question about the channels and the pipes part that you covered in the architecture. Is pipe the computation part when it compared to typical streaming, or is there a way to scale pipes compared to the channel? I don't know if I fully understand this question, but I'll leave it to you to.
Yeah. So what's interesting, and I'm also kind of reading in between the lines a little bit on that question. So you can think of the pipe, it does provide some stateful processing. So you can kind of recast your data. You can do some parsing of that data. You can, do a couple different things, which we call simple, stateless transforms. I might have said stateful earlier. Sorry, stateless transforms. So we're not doing anything like joins or more complex windowing that comes up in stream processing, but you can definitely do some, quick jobs on your data, make it easier for you to do maybe downstream stuff within that pipe. The other thing the streaming pipe allows us to do is cluster your data. So this is really important for, high throughput workloads that also are querying that data. Clustering is basically organizing that data. So when you go to query it, the query is much more performant and much faster, and also usually less costly. So this is another value add feature that is new in our V2 architecture. So pre-clustering is kind of our nickname for it, also very important. And you can think of that as well as some processing that is done within the pipe. Now with Snowpipe streaming, we support up to 10 gigabytes into a table of streaming ingest. And to get to that level, it typically requires multiple pipes. You have multiple pipes going to a table, as well as multiple channels. So each channel has some limits that we document. And so you're going to want to horizontally scale out the number of channels you need, as well as the number of pipes you need to hit your ingestion targets.
Got it. Okay, so that's helpful. So you can scale the pipes to be able to run the lightweight transformations, if I can say, that are stateless. That is fantastic. And I know, like in the ingestion options that we had covered earlier, we talked about OpenFlow and Snowpipe streaming, but there is also another option, which is Snowpipe itself, which I know briefly that I would potentially consider Snowpipe for more of a batch processing workload, not necessarily like a real-time streaming workload. But you tell me how should I think about using Snowpipe versus Snowpipe streaming?
Yeah. Also, something I think is super important for our customers to understand as well. We've had some pricing changes on Snowpipe as well, and so they're also matching, Snowpipe streaming in certain aspects as far as that goes to simplify things for our customers. And so, it really does come down to the use case of the specific customer use case. And so, you think of batch and streaming. And if you're thinking batch, I'm sending batch data into Snowflake, and maybe you're not doing it as frequently, or these batches are quite large. Snowpipe is a fantastic product for that. The other aspect is latency. So with Snowpipe streaming, we are targeting under 10 seconds. We saw in the demo, on average, it was coming in 4 seconds. So if latency is important, that's when you start coming into kind of that streaming world, and Snowpipe streaming is going to be a better fit for you. And I say that because a lot of our customers are doing micro batch streaming, right? So they're sending in batches of rows. And so it starts to get a little bit confusing, but I think it depends on how often that data is coming in and your latency profile that you want to achieve. So anything under a minute, you want to start really thinking about Snowpipe streaming. And anything that is greater than that, more batch focus, Snowpipe is a fantastic product for that.
Yeah, and I think I just want to add on, totally agree with, what Chase was saying, and just want to echo on that. I think for streaming, like we said, right, it's really for your mission critical, use cases. If it's like under minutes or sub-seconds, definitely look into our streaming, Snowpipe streaming for your real-time ingestions workloads. Anything that is like you said, right, batch, Snowpipe will be great for that one. It also allows, loading data files as soon as they're available in stage, right? So that means that you can always load from files into like micro batches. So it's like available for our users.
Also, apparently we have this price
Correct.
for the customers. So that's all the more reason to check that out too. Awesome. And I have one more user question before we wrap it up. Mahesh asks, what are the best practices in Snowflake streaming? Is there any size limitations in streaming formats that one needs to be aware of?
Yeah, so we do have some limitations and best practices that we document today in our high performance architecture documentation that's publicly available. That's going to be the best resource. But typically we do have some different size restrictions. One thing we didn't talk about is we do have a REST API as well for customers that want to do lightweight ingest into Snowflake that don't want to rely on a client SDK. And the reason I bring that up is that has some lower limits and size restrictions that users need to be aware of. And then for file formats, really our SDK handles that. But for, raw ingest into Snowpipe streaming, we currently use JSON for all of that to make it really easy. But it also helps support additional features that we have coming up on the roadmap that will be pretty exciting for developers.
I think I quickly looked up the next gen architecture blog that you had put together, Chase, and it tells me for the throughput, it supports up to 10 gigs per second. That's a lot of data for the ingestion that we're talking about here. So that's
right.
the size limitations that we're talking about. So that's helpful to know. All right. I think we had everything. We talked about, firstly, we had Snowpipe streaming V2, or the high performance version that has been in GA for a month now, but it's a good time today to talk about what has changed and how could a developer today take advantage of this. And thanks, Chase, for sort of putting together the demo, showing us examples all the way up to even error handling and sort of, miscellaneous cases and whatnot. Before we wrap up, is there any last minute call outs that you want to do, or anything that you wanted to mention but didn't get a chance to?
I think the main thing is we have a lot of exciting features that are going to help developers more easily stream into Snowflake. So we really focus on performance and latency We want to make that even better, even lower as we move forward. But then also we have some really exciting developer ergonomic features coming up that's going to make it easier for developers to stream into Snowflake. So stay tuned for announcements and things like that around our product.
Yeah, I think for my side, just wanted to reiterate, like it's already GA on AWS, GCP, and Azure. So really check it out. And then we have some really great, technical documentations out there already. We can definitely drop the link in the comments or after the recording. So yeah, really excited. And then Vino touched on the blog announcement. There's a really cool, customer case study from our financial industry, SIBO. They have been like one of our earliest testing preview customers. And so they're really loving streaming V2 so far. So yeah, reach out to Chase or myself for any questions via LinkedIn.
All right, that's it. Thank you so much, Maria and Chase. And for the folks watching, go check out Snowpipe Streaming V2, and we'll also share the blog, that Chase had authored, and also other documentations for you in the comment section, so you can go check it out. And yeah, come back with any feedback, thoughts, feature requests. I know the product managers love feature requests, don't they? So come back with anything that you have, and we'd be happy to hear all the feedback from you. Thanks, everybody, and thanks, Maria and Chase. See you all next week.
Thank you all.